Alright, so this is another review. This one is for chemistry. And again, this review, it goes along with the quiz. These are notes on the most missed questions. So first up, equilibrium reactions. If you add products or remove reactants, is going to shift towards the reactants, right? Because it wants to be equal. So if there's more of one thing than the other, it's going to shift to balance that out. So if you remove reactants, it wants to make more reactants. If you add products, it's going to want to make reactants to even things out. If you add reactants or remove products, it's going to shift towards the products. Okay? Pause the video if I go too fast and you need to rehear something or write something down. I would be familiar with these trends. Ionization energy is the energy required to remove an electron, and it increases from left to right and bottom to top. Now this makes sense because if you think about metals, all right, the metals are all over here, right? Francium is the most metallic metal, and so it wants to give away electrons, okay? And so it has a really low ionization energy. It doesn't take a lot of energy to remove an electron because it already wants to give it away. But over here, fluorine has a really high ionization energy. It does not want to lose electron, it wants to gain electrons. All right? So it makes sense that ionization energy would increase from left to right and from bottom to top. Okay? Electron affinity is how well the atom attracts electrons, and it increases from left to right and bottom to top. So if you think again about fluorine, fluorine is the most non-metallic element, and it really wants to gain electrons. So it has a very high electron affinity. All right? Francium over here does not want to gain electrons, so it has a very low ionization energy. So ionization energy and electron affinity, they're not the same thing, but they follow the same pattern on the periodic table. Atomic radius is the size of the atom, and so it increases from right to left and from top to bottom. So francium is a big element. Something like helium is a very small element. Okay. This equation, Q equals mc delta T, is on your reference table. So if you get an equation like this, or a problem where it says like this much energy was added, the temperature changed from this to this, the mass is this, what is the specific heat, this is the equation you use. And you just plug in your values and you solve. All right, so be familiar with what the Q, the M, the C, and the delta T stands for. Delta is the triangle. It just means that there's a change in something. Delta D would be change in distance. Delta T is change in temperature. All right, cations are positive ions. Usually these are metals. Anions are negative ions. These are going to be nonmetals. Dissociation is where an ionic substance dissolves in water and it separates into ions. The metal is going to become a cation, and the nonmetal is going to become an anion. In which figure, not to scale, would the transition of the element of the atom produce an emission line? Remember, emission lines occur when the electrons fall to a lower energy level. In A, C, and D, those are excited electrons. They're moving up to a higher energy level. Now, be careful, because like this one, the arrow is pointed down, but it's still going to a higher energy level, because this is a circle, right? All right, so this is still going to a higher energy level. The only one where the electron is going to a lower energy level is B. A neutral atom has a ground state electron configuration of 1s2, 2s2, 2p6, 3s2, 3p3. The neutral atom becomes an ion during a chemical reaction. What is most likely the charge of the ion? All right, so first of all, you need to know that valence electrons are in the outermost s and p orbitals. Once you know the number of valence electrons, in this case, look up there, how many electrons are in the 3s and the 3p combined. But you know that, you can predict how many would be lost or gained. So this element has 5 valence electrons. 5 is too many to lose, so it's going to gain 3. And when you gain electrons, you become negative. So it would be a 3 minus electron ion. So for example, 1s2, that would be helium, has a full outer shell, it's not going to make an ion. 1s2, 2s1 is lithium, it has 1 valence electron, so it's a 1 plus ion. 1s2, 2s2, 2p5 is fluorine, that has 7 valence electrons. It's going to gain 1 to have 8. That makes it a 1 minus ion. You should be able to calculate the molecular mass and the molecular formula given the empirical formula. Okay. We've done that in CK12. We've done that in practice. Basically, the first thing you do is find the mass of the empirical formula. So this empirical formula is CH2O. So that's 12 for the carbon, 2 for the hydrogens, and 16 for the oxygen. So that's 30. The molecular mass, we are told, is 90. So we take the molecular mass, divide it by the empirical formula mass, and we find that there are 3 times as many carbons, hydrogens, and oxygens in the molecular formula than in the empirical formula. So 3 times 1 carbon is C3. 3 times H2 is H6, and 3 times oxygen is going to be O3. Right? And then that would be the C3H6O3 would be your final answer. From grams of zinc to moles of zinc to moles of zinc from moles of zinc to moles of zinc, and then, all right, so then we're going to change from moles of zinc to moles of hydrogen, and then we're going to change from moles of hydrogen gas to grams of hydrogen gas. And then this is how you set it up, and it's pretty straightforward. Can't see my, all right. You have grams here, grams of zinc. So there are 65.39 grams per mole. So 65.39 with 1 mole over top. Grams cancel. Then we take and put 1 mole down here. And when we do that, our moles of zinc cancel, and then our moles of hydrogen gas cancel. This is the mole ratio, by the way. This is the molar mass. All right, and then we use the molar mass of hydrogen. All right, and that gets us here. Now you'll notice that it's 2.016 instead of 1.008. That's because this is H2. Okay, so there are 2 hydrogens in H2, so it's 2.016. So then we just multiply across the top. 5 times 2.016 divided by 65.39, and that's your answer. Okay, so that's how you go from grams of one thing in an equation to grams of something else. Remember, the mole ratio comes from the chemical equation. Okay, that should be a Q, not a G. All right, and that's the last one. That is the chemistry review from the quiz. Hope you've had a good day. Tomorrow we'll take some notes and for review, maybe do a booklet and do a exit ticket.